लाईट आहे ना? त्या क्लासमध्ये लाईट नाही. त्या क्लासमध्ये नाही बघून घ्या ना जरा. या लोक काम करतात तर बंद केलं जरा. नाही बंदच केलं मी. रेकॉर्डिंगच चालू करायची होती फक्त. चालू केली रेकॉर्डिंग. नाही नाही इकडे. वर्ष बंद केलं का विचार येत झालं चालेल. नाही आणून ठेवलंय मी. Good evening. Are you able to hear me clearly?
Yes, sir.
Okay. So we'll just wait for 1 more minute. We'll let others to join and then we'll start the lecture in next 1 minute. Okay. We had already started with the numericals, I guess. So we'll just move ahead with that. So I think so last numericals we had done to find out the principal values, right? So let's
Yes,
move
sir.
ahead now. Next numerical is alpha is equal to 3 sine inverse of 6/11 and beta is equals to 3 cos inverse of 4/9. Where inverse trigonometric functions can take principal values only. Functions can take principal values only, then correct option is or are. Then correct option is or are option number one, cos beta is greater than 0. Option number two, sin beta is less than 0. Option number C, cos of alpha plus beta is greater than 0. And option number D is cos phi is less than 0. Now this is coming 2015 advanced. Okay, this numerical has come in AEE advanced. In 2015. Okay. So now when the numericals have come in advance, those will have multiple options as right. The advanced numericals will have multiple options as right, and therefore here written over here is option is or options are. So there may be multiple options which are right over here. One. The board seems to be clear. If you are able to see me clear, then board should also be clear.
No, sir.
If
Now the board is not
less,
clear.
then also it happens. The same to use every time. Last time also I used the same mobile. Just a minute. Just a minute. I'll just come and back. Are you able to see the board clearly now? Or still it's blurred? Is the board blurred? एक वेळा तुम्ही हे लॅपटॉप मध्ये बनवून घ्या जरा. तुमचा कोणताही व्हॉट्सअप ओपन करा आणि तुम्हाला लिंक पाठवतो. Okay, let's start. If it is blur, I think so in video it will be okay. Suppose many times it happens if the speed is less, no, internet speed, then also it happens. We'll see. Now you just concentrate on this question. He has given us the alpha as 3 sin inverse of 6 by 11, and the value of b. And then he's saying that the inverse trigonometric functions can take principal values only. Okay, so the principal values of sine will be between minus pi by 2 to plus pi by 2. If you remember, principal values are in the domain. Okay, that is in the fundamental series. And for cos inverse, the domain is 0 to pi. So the angle will be able to take the values between 0 to pi. This we have to remember. And next, he is saying correct option is or correct options are. So when it is okay, JW advanced numerical, always multiple options will be correct. Okay, in most of the cases, multiple options will be correct. So you have 4 options are there. So there is a possibility that we can get more than one option correct. Okay, so let's solve it. So let's take this 6 upon 11. So 6 upon 11 is greater than 1 by 2. Yes. Okay, 6 divided by 11 is greater than 0.5. So it is obviously greater than 1 upon 2. Now here sine inverse, I'll write sine inverse on both the sides. Therefore, I can say sine inverse of 6 by 11, sine inverse of 1 by 2. Now we are doing like this because we know only the values for the standard angles. We know only for the standard values. Standard values which we get for sine and cos are 0, okay, root 3 by 2, 1 by 2, 1 by root 2 and 1. These are the standard values which we know, and that's why I am comparing it with the standard value. Clear hai na? Okay. Next, here it is written 3, so I'll multiply by, before that, sine inverse of 6 by 11 is greater than sine inverse of 1 by 2. Sine inverse of 1 by 2 will be how much? Sine inverse of 1 by 2, 30 degree. Right? 30 degree means pi by 6. Okay. Next he is saying 3 sine inverse of 6 by 11. So I multiply by 3 on both sides. So I get 3 sine inverse 6 by 11 is greater than 3 into pi by 6. So that is I get 3 sine inverse 6 by 11 is greater than 3 1s are 3 2s are pi by 2. And this 3 sine inverse of 6 by 11 is nothing but alpha. And therefore I can write, instead of 3 sine inverse of 6 by 11, I can write alpha is greater than pi by 2. Till here is it fine? So if my alpha is greater than pi by 2, right, which means my angle will be in the second quadrant. In second quadrant, then which of these things will satisfy over here? So if I take cos alpha, and if alpha is greater than pi by 2, for cos the domain is between 0 to pi. So I can take a value which is greater than pi by 2. If I want to verify it for sine, I cannot take value which is greater than pi by 2. Because sine inverse, the domain is minus pi by 2 to plus pi by 2. But if you see, alpha options are only one. There is only one option which is related to alpha. All other options are related to beta. And here we have alpha plus beta. So I'm not going to check for the sine. And here I'm going to check for the cos. So if alpha is greater than pi by 2, it involves it. It means it is in the second quadrant. In second quadrant, my cos is negative, and therefore it implies my cos of alpha will be less than 0. So this gives me answer option D. Till here it's clear. What I've got is I've got the value of alpha is greater than 2, which means it is lying in the second quadrant. Okay, it means in second quadrant our cos is negative, and therefore I can write cos alpha. The value of cos alpha will be less than 0 because it is negative. So one we get answer as option number D. Now we have to verify for beta also. We can get multiple options right over here because it is advanced numerical. Okay, and here he is mentioned also is or R. Okay, so let's check for beta. So for beta we have over here 4 by 9. So I can write my 4 by 9 is less than 1 by 2. Yes or no? 4 divided by 8 will give me 1 by 2. 4 divided by 7 will give me a ratio which is greater than 1 by 2. 4 by 9 is what obviously less than 1 by 2. Now what I have over here cos inverse. So I'll write cos inverse on both the sides. So cos inverse of 4 by 9 is less than cos inverse of 1 by 2. Here in the question we have 3 cos inverse, therefore I multiply by 3. Before that, cos inverse of 4 by 9 is less than cos inverse of 1 by 2. 1 by 2 is cos of 60 degree. Cos 60 is 1 by 2, that is pi by 3. So here I'll get pi by 3. Okay, therefore I can write 3 cos inverse of 4 by 9 is less than 3 into pi by 3. So 3 gets cancelled, so I'll get 3 cos inverse of 4 by 9 is less than 5. Okay, and this 3 cos inverse of 4 by 9 is nothing but beta. So we get to know that my beta is less than 5. That is again, my beta is an angle again which is lying in the second quadrant because it is less than 5. So this angle is also lying in the second quadrant. So in second quadrant my cos is 0, cos is negative. So this option I will not get. Cos beta should be less than 0. Cos beta cannot be greater than 0 because I am getting it as lying in the second quadrant. Similarly, in second quadrant, my beta what I've got is less than 5. So it will lie in the second quadrant. In second quadrant, my sign is positive. So when I write sin beta, I should get positive value. But here what is written in the option, sin beta is less than 0. So this will also not be right. Now next we have to see alpha plus beta. Now if you see this 6 upon 11, it's okay, not 1 by 2, but slightly greater than 1 by 2. Similarly, if we see here, okay, 4 by 9. So 4 by 9, what does it imply? It implies that my alpha is only slightly greater than pi by 2. Not very much greater than pi by 2, which means it is going to be near about pi by 2, not exactly pi by 2. Similarly, my beta is less than pi, and this 4 by 9 is slightly less than 1 by 2. It implies that my beta is slightly less than 180. It is not very much less than 180, but it is slightly less than 180, and this is slightly greater than pi by 2. If I write something like this, and for beta if I write pi, so pi plus pi by 2 plus pi will give me 3 pi by 2. From the given questions, it implies that my alpha plus beta will be slightly greater than 3 pi by 2. That is 270 degrees. Okay, do you agree why I have written slightly greater? Because the ratio which they have given us in the beginning, 6 by 11, is slightly greater than 1 by 2, which implies my alpha is slightly greater than pi by 2. Similarly, this 4 by 9 is slightly less than 1 by 2. Because if it was 4 by 8, it would have become 1 by 2. So it is slightly less than 1 by 2, which implies my beta is slightly less than 180 degrees. So one angle is slightly greater than 90 degrees, whereas other is slightly less than 180 degrees. Therefore, the addition I'll get will be slightly greater than 270 degrees. So if it is slightly greater than 3 pi by 2, only slightly, not more, so it is going to be in the fourth quadrant. Now, if it is lying in the fourth quadrant, my fourth quadrant cos is positive. So here I have cos of alpha plus beta greater than 0. So yes, this option is also correct. The cos of alpha plus beta will be greater than 0. So this option is also correct. So multiple options are correct over here. So in this case, option number C and option number D both are correct. Is this numerically clear? If you have not understood anything, please ask me. This has come in your GW Advanced 2015. If you have not understood, then please ask me. Everyone has understood. Everyone has understood. So here there are two options correct. Okay. Option number C and option number D. Okay. Let's do next numerical. This has come in 2011. 2 tan inverse of 3 by 4 minus tan inverse of 17 by 31 is equal to option number A, pi by 6, option number B, pi by 4, option number C, pi by 8, and option number D, pi by 2. This is come in 2011. So now you cannot directly apply the formula. We have one formula for tan inverse of x minus tan inverse of y, which is nothing but tan inverse of x minus y 1 plus xy. But we can apply this formula when I have this tan inverse of x minus tan inverse of y. But if I see over here, I don't have tan inverse of x. Instead, I have 2 tan inverse of 3 by 4. Then how should I do this? I could have applied this formula, but there should have been like this. If it was like this, tan inverse of 3 by 4, I could have directly applied this formula. But since I have 2 over here, I directly cannot apply the formula. How we will split it? How you will split 2 tan inverse? You will write it as tan inverse of 3 by 4 plus tan inverse of 3 by 4. Instead, if you remember, I had given a formula for this 2 tan inverse of x. And if you remember, I said, remember the formula of tan 2x. That is 2 tan x upon 1 minus tan square x. So similarly, 2 tan inverse of x can be written as 2 tan inverse of 2x upon 1 minus x square. We had written this formula. Okay, so this formula I can apply over here. So this 2 tan inverse of 3 by 4 can be written something like this. Tan inverse of 2x, instead of x we have 3 by 4 upon 1 minus x square. So that will be 9 by 16 minus tan inverse of 17 by 31. So I get tan inverse of 2 ones are 2 twos are. So this becomes 3 by 2 upon 16 minus 9 by 16 minus tan inverse of 17 by 31. So I'll get tan inverse of 2 ones and 2 eights are. So this will become, this 8 will come up. So 3 into 8 upon 16 minus 9. That will be how much? 7 minus tan inverse of 17 by 31. So that will be tan inverse of 24 by 7 minus tan inverse of 17 by 31. So now I have gotten this format. So now I have got this numerical in this format. So now I can apply this formula. Tan inverse of x minus tan inverse of y is nothing but tan inverse of x minus y, 24 by 7 minus 17 by 31 upon 1 plus x into y. 1 plus 24 by 7 into 17 by 31. Come on, solve it and let me know how much is the answer. Solve it and tell me how much is the answer. We will have to take LCM. 24 into 31 minus 17 into 7 upon this will get cancelled. Same calculation is over here. So 31 into 7 plus 24 into 17. Tell me how much are we getting? 31 minus 17 into 7 divided by 31 into 7 plus 24 into 17. Solve it and let me know how much it is. It somewhere comes around, I think so, 625 upon 625. So I get these are calculation speed. Let's do next numerical. This is also come in 2011. Next numerical is also come in 2011. Tan inverse of 2x upon 1 minus x square plus cot inverse of 1 minus x square upon 2x is equals to pi by 3. Then tan inverse of x is option number A, pi by 3, option number B, pi by 6, option number C, pi by 12, and option number D, pi by 4. Will you be able to solve this? Tan inverse of 2x upon 1 minus x square plus cot inverse of 1 minus x square. So if you see over here, the terms inside are similar. So we can take advantage of this. We very well know that cot inverse of x is nothing but tan inverse of 1 by x. So now here, instead of cot inverse of x, I can write tan inverse of 1 by x. That is, it will become the reciprocal of this. Therefore, I can write this as tan inverse of 2x upon 1 minus x square plus, instead of cot inverse, I can write tan inverse of. So it will become reciprocal of this. So this will become 2x upon 1 minus x square. So the same term is there, so which will be written as 2 tan inverse of 2x upon 1 minus x square. So now we can apply the formula of pi by 3 equals to pi by 3. Now we can apply the formula of 2 tan inverse of x, which we had applied in the last piece also. What is 2 times tan inverse of x formula? Tan inverse of 2x. Instead of x, we have this entire term. 2x upon 1 minus x square upon 1 minus x square. Instead of x square, we have this entire term 2x upon 1 minus x square, the whole square, is equal to pi by 3. Okay, I'll take this term over there. So if tan inverse, it goes over there, so it will become tan, and here I'll get 2 into 2, so that is 4x upon 1 minus x square, the whole upon, here if I take LCM, 1 minus x square, the whole square, minus, over here I will get 4x square, the whole upon 1 minus x square, the whole square, is equal to this. Tan inverse comes over here, so it will become tan. It will become tan of pi by 3. So 1, this and this will get cancelled. 1 minus x square will come up. So I will get over here 4x into 1 minus x square upon here 1 minus x square, the whole square, minus 4x square is equals to, how much is tan of pi by 3? Or if you want, you can keep it like this only, because the options which are there is it is in terms of pi something, and we need to find out the value of tan inverse of x. So let us keep tan here only. Simplify this and let me know how much you get. Simplify this and let me know how much you are getting. Simplify it. Let me know how much you are getting. Or we can do one more thing over here if it is getting complex. If we write the formula for 2 tan inverse of x, so that is tan inverse of 2x upon 1 minus x square. Okay. So if we see over here, we are getting the similar term. We are getting this term over here also. If we don't apply this formula and if we consider only this much part. So instead of this, I can write over there 2 tan inverse of x. So instead of solving this is becoming complex. We can write here it as, instead of this is the exactly this term. I can write over there 2 tan inverse of x. So here this 2 is already there, and instead of this tan inverse of 2x upon 1 minus x square, I'll write over here 2. Instead of this, I'll write 2 tan inverse of x is equals to pi by 3. So 2 into 2, 4, 4 goes over there. So directly I'll get tan inverse of x is equals to pi by 3 into 2, that is pi by 12. So we have this option number C. Everyone understood? This is becoming complex. This calculation was becoming complex. Just an investigation leads us to that this in exactly this term I'm getting over here, for which I can put over there 2 tan inverse of x. Is it clear? Any confusions in this? Any confusions in this? That calculation was becoming complex and getting this would have become difficult. Everyone has understood this step? Okay. Okay, so let's do next numerical. This is coming 2010. Tan inverse of 1 by 4 plus tan inverse of 2 by 9 is option A 1 by 2 tan inverse of 3 by 4. Option B 1 by 2 tan inverse of 4 by 3. Option C 1 by 2 tan inverse of 6 by 5. And option D is none of this. At first instant, it will seem very simple to you, but when you investigate the options, you will understand that we are not going to get directly the answer which is given in the option. We'll have to do some adjustment. After that, only we'll be able to get this given option. So, straightforwardly, we can directly apply the formula tan inverse of x plus tan inverse of y. So we have this formula tan inverse of x plus tan inverse of y is nothing but tan inverse of x plus y upon 1 minus x1. This will give me tan inverse of xy, so 1 plus 4, 1 by 4 plus 2 by 9, 1 minus 1 by 4 into 2 by 9. So that will give me tan inverse of 9 plus 2 upon 4 into 9 and divided by 4 into 9, that is 36, minus 2 upon 4 into 9. So I'll get tan inverse of 11 by, did I do a mistake? Yes, 9 plus 4 into 2, that is 8. Sorry. So this will become 17 by 34. 9 and 8. Right. On 36 minus 2. Right. See how much am I getting? Tan inverse of 17 by 34. But if I see the options, all the options are in the term of 1 by 2 tan inverse of something, 1 by 2 tan inverse of something, 1 by 2 tan inverse of something. So I will have to bring this and then we can say that it is none of this. Directly, we cannot say the answer is none of this. Okay, I will have to bring this term over there. How can I bring this term over there? How can I bring this term over there? We cannot directly tell the option is none of this. This is nothing but 17 ones are 17 twos are. So now he wants 1 by 2 over here. So that is what I will do. 1 by 2 into 2. I'm just doing adjustment tan inverse of 1 by 2. This 2 I am taking outside. I am just writing it as 1 by 2. Tan inverse of 1 by 2. Till here, is it clear? So since he wanted like this 1 by 2 something, so that is why I've written something like this. So I can just remove this, instead I can write this as 1 by 2 into 2 because I need here. So now I can apply the formula of 2 tan inverse of x. The formula for 2 tan inverse of x is tan inverse of 2x into 1 minus x square. So 1 by 4. So that will give me 1 by 2 tan inverse of 2 get cancelled. So 1 upon 4 minus 1 upon 4. So I'll get 1 by 2 tan inverse of 4 by 3. So see, we get the option 1 by 2 tan inverse of 4 by 3, which is there as option number B. So if we could have ended over here, we would have got wrong option, we would have selected this. I have time and again said you guys that they will always give you options such that if you make a mistake, you can confidently do wrong and come in the exam. Okay, we'll just look over here and we'll say I am getting tan inverse of 1 by 2, which is not over there. So you will directly select option none. Okay, but if you do that, you would have made mistake. You always see the other options. So when we saw other options, all the options had 1 by 2, 1 by 2, 1 by 2. Okay, so it made us think that maybe the possibility is there. This 1 by 2, 1 by 2 is also there. Let us try. So when we are trying, we are getting this option number B. Okay, so be careful such for such kind of numerical. Okay, let's do next numerical, which this has come in 2009. This numerical had come in 2010, which we just solved right now. The next question has come in 2009, which is cot inverse of under root of 1 plus sin x plus 1 minus sin x upon root of 1 plus sin x minus 1 minus sin x is option number A, x by 4. Option number B, x by 6. Option number C, x by 2. And option number D, x by 3. If you see here, the question is looks bit. Where is the options which are asked? Where is the options which are there? Okay, this is a very small x by 4, x by 6, x by 2, x by 3. It indicates that we will have to simplify this first and then we'll find out cot and inverse. So how we are going to do it? You can rationalize also because similar terms are there and your minus is there, your plus is there. So to remove the square root, you can do rationalization also. So one way is you can do rationalization and the other way is instead of going for the rationalization, since it is trigonometry, we can apply trigonometric formulas. So 1 plus minus sin x, this can be written as sin 2 theta is 2 times sin theta into cos theta and 1 is sin square plus cos square and therefore I can write this as instead of 1 I can write sin square x by 2 plus cos square x by 2 plus minus because here I have plus, here I have minus. Therefore, I am writing plus. Instead of sin x, I can write 2 times sin x by 2 into cos x by 2. Therefore, 1 plus minus sin x is going to give me the expansion of sin x by 2 plus minus cos x by 2 the whole square. Okay, because you have this, if it is plus minus, so this. So if it is plus, this is going to be plus, this is minus, this is going to be minus. So I can substitute these values over here and therefore I can get cot inverse of, instead of under root of 1 plus sin x, I can write sin x by 2 plus cos x by 2 the whole square plus, instead of 1 minus sin x, I can write sin x by 2 minus cos x by 2 the whole square. Same thing I can write down also. So this will also be sin x by 2 plus cos x by 2 the whole square minus here also I can write sin x by 2 minus cos x by 2 the whole square. So the square and square root will get cancelled. Therefore, I will get cot inverse of, here I am going to get sin x by 2 plus cos x by 2 plus here sin x by 2 minus cos x by 2. Similarly, here I am going to get sin x by 2 plus cos x by 2 minus sin x by 2 minus minus will become plus cos x by 2. So here cos and cos is getting cancelled out. Here sin and sin is getting cancelled out. So 2 sin x by 2 in numerator, 2 cos x by 2 in denominator. So 2 and 2 will also get cancelled. So I will get cot inverse of tan of x by 2. Now Next, how we can do? You have almost got the answer. Or you could have written over there, if we are getting tan over here, we could have written over here instead of sin x by 2 plus minus cos x by 2, we could have written over here, then it would have become easy. We would have got the answer easily. Sin x by 2. So here what will happen if I write something like this? Then here my sin will get cancelled and here my cos will get cancelled instead of sin. Okay, here my cos will get cancelled. So instead of tan x by 2, if I write here cos x by 2 minus sin x by 2, then here I'll get cos of x by 2. So cot and cot inverse will get cancelled and I'll get x by 2. In first, it will not click us directly. Okay, when we wrote over here, then it clicked because if I want to convert tan into cot, okay, if I want to convert tan into cot, then cot is 1 upon tan. So tan I could have written 1 upon cot, and if I would have written like that, then I wouldn't have been able to cancel directly. Okay, then I would have written, then to write tan into cot, I could have written pi by 2 minus x by 2. And then cot and cot inverse would have got cancelled. But again, that option is not there over there, pi by 2 minus x by 2. And therefore, we had to make change over here. So instead of writing sin x by 2 plus minus cos x by 2, I have written the opposite, cos x by 2 minus sin x by 2. So I will be able to match the answer. Okay, hope you have understood. It will not click at the first that we should write like this or we should write like this. The question will only tell us. Okay. Next question. This is coming 2012. Tan inverse of x by y minus tan inverse of x minus y upon x plus y is option number A, pi by 4, option number B, pi by 2, option number C, pi by 3, and option number D, pi by 6. This is coming 2012. Can you try? This is simpler one. This is simpler one. You directly apply the formula of tan inverse of x minus tan inverse of y. You will get the answer. Apply the formula for tan inverse of x and tan inverse of y and just simplify it. You will get the answer. It is very simple one. So we have the formula tan inverse of x minus tan inverse of y is nothing but tan inverse of x minus y upon 1 plus xy. Here instead of x we have x by y and here instead of y we have x minus y upon x plus y. So this will give me tan inverse of x minus y. So instead of x we have x by y minus y. Instead of y we have x minus y upon x plus y. The whole upon 1 plus xy. So 1 plus x. Instead of x we have x by y. Into here we have x minus y upon x plus y. Just simplify it, you will get the answer. Just simplify it, you will get the answer. It will be tan inverse of x minus x minus y upon here y into x plus y plus x into x minus y. So when we take LCM, this term will get cancelled. So I'll get tan inverse of, when I open the bracket, x will get cancelled. So no, sorry. When I take LCM, this will be x into x plus y, and this will be minus y into x minus y. Sorry. So I'll get x square plus xy minus xy minus minus plus y square upon here xy plus y square plus x square minus xy. So plus xy minus xy gets cancelled over here. Here also plus xy minus xy gets cancelled over here. So I'll get tan inverse of x square plus y square upon here also x square plus y square. That becomes tan inverse of 1, which is nothing but pi by 4. So our answer is option number A, that is pi by 4. Okay, so the answer is option A, which is pi by 4. This was very simple one. Let's do next numerical. This has come in 2009 in AIEEE. Tan inverse of root 1 plus x minus root 1 minus x upon root 1 plus x plus root 1 minus x is option A, pi by 4 minus cos inverse of x. Option B, pi by 4 plus cos inverse of x. Option C, pi minus 1 by 2 cos inverse of x. Option D, pi by 4 minus 1 by 2 cos inverse of x. Just give it a try how we are going to do it. So again you can go for rationalization. The algebraic terms are there. You can go for rationalization also, but again I have tan inverse over there. Instead I can apply and I can go for trigonometry because we are doing trigonometry. So instead of rationalization I will again go for trigonometry only. Okay. So here you have 1 plus x, 1 minus x, in the option you have cos inverse. So we have the formula 1 plus cos 2 theta is 2 times cos square theta, and 1 minus cos 2 theta is 2 times sin square theta. Okay. So and in the option also we have all the options, we have cos inverse. So therefore, and I have this term, therefore I can put, let x is equal to say cos of theta. So I'll get over here tan inverse of 1 plus, I can take cos 2 theta minus 1 minus cos 2 theta upon root of 1 plus cos 2 theta plus under root of 1 minus cos 2 theta. So I will get tan inverse of 1 plus cos 2 theta is 2 times cos square theta. Similarly, 1 minus cos 2 theta will be 2 times sin square theta. Similarly, here 2 times cos square theta plus over here 2 times sin square theta. So I'll get tan inverse of here square and square root will get cancelled. Here will I have root 2, here also I will have root 2, here also root 2, here also root 2. I'll take root 2 common in numerator and denominator and I'll cancel it out. So here what remains will be cos theta minus sin theta. Here also square and square root gets cancelled. So here cos theta plus sin theta. Okay. Here I can write it as. So now again we have to think over here. So if I divide numerator and denominator by cos theta, then I'll get 1 minus tan theta upon 1 plus tan theta. And 1 can be written as tan of pi by 4, and therefore I will get, here is my hint. So I'll get tan inverse of tan of pi by 4 minus tan of theta upon 1 plus tan of pi by 4 into tan of theta. So tan A minus tan B is this, tan A minus tan B upon 1 plus tan A into tan B. So this becomes the formula for tan of A minus B. So now tan and tan inverse get cancelled. So I will get pi by 4 minus theta. So now I will resubstitute the value of theta. So from here, I will get 2 theta is equals to, if cos goes over there, it will become cos inverse of x. I need the value of theta. So I will get theta is equal to 1 by 2 cos inverse of x. So I'll put the value of theta over here. So I'll get pi by 4. The value of theta is 1 by 2 cos inverse of x. So our answer is option number D. Okay, pi by 4 minus 1 by 2 cos inverse of x. Is this clear? Clear? Any doubts in the question? Any doubts in solution? Okay then. We'll go for the next numerical. If you don't have any doubt, we'll go for the next numerical. So next is tan of 1 by 2 into sin inverse of 2x upon 1 plus x square plus cos inverse of 1 minus y square upon 1 plus y square is option A, x plus y upon 1 minus xy. Option B, x plus y upon 1 plus xy. Option C, x minus y upon 1 plus xy. And option D, x minus y upon 1 minus xy. How should we solve this? Can anyone tell me how to solve this? How to solve this? Think and tell me. Can anyone tell me how we can solve this? Do you? Formulas which I had already shared with you as PDF in the group. If I had the formula, convert it is going to benefit you. You have tan over there. And if you see the answer and the options over here, it clearly says that you should go over there tan inverse so that tan and tan inverse will cancel and you can get this kind of an answer. The option is telling you that you cannot do that. The option tells you that you should get over there somehow tan inverse and you should be in a position to move 1 by 2. Then only you will be able to cancel tan inverse. This also should not be there, and this sine and cos inverse both should have somehow get converted into tan inverse. Then only this tan and tan inverse will get cancelled and you can get this kind of a thing. That is why I say inverse trigonometry could not be done without formulas which I had given you as properties. This chapter is very easy, but if you don't remember the formulas, you will not be able to solve. I had given you formula for 2 tan inverse of x. I had given you 3 formula. One formula was in terms of tan, and the other 2 formulas are in terms of this, and it is exactly this. You don't even have to scratch your head. The formula for 2 tan inverse of x is exactly this in terms of sine and exactly this in terms of cos. And I had said you can remember it as cos 2 theta is 1 minus tan square theta upon 1 plus tan square theta. That is this term you are getting. And sin 2 theta is 2 tan theta upon 1 plus tan square theta. So you have this 2x upon 1 plus x square. If you remember, which is 2 tan of x, tan inverse of x. So instead of this also I can write 2 tan inverse of x, and instead of this also I can write 2 tan inverse of x. Therefore I will get tan of 1 by 2. Instead of this I can write 2 tan inverse of x plus, instead of this also I can write 2 tan inverse of x. So I'll get tan of 1 by 2. Here also 2 is there, here also 2 is there. I can take common. So here I'll get tan inverse of x plus tan inverse of x. So this 2 and this 2 get cancelled. So I'll get tan. Oh, sorry. Here you have y. So this will be tan inverse of y. Sorry. Here you have y, so I will have to write here y. Here I have x in the question, so here I will have to write x. So 2 get cancelled. So now I have tan inverse of x plus tan inverse of y is nothing but tan inverse of x plus y upon 1 minus xy. So now this tan and this tan inverse gets cancelled and I'll get x plus y upon 1 minus xy. So this is the answer. So which is our option number A. Your answer is option number A. So see here, if you are not remembering the formula, such a simple, just in 1, 2, and 3 steps we got the answer. But if we don't remember the formula, we cannot do it. Okay, the numerical was simple. The only thing which was needed over here is we will have to bias all the properties which are given to you, without which we will not be able to do numericals in this. This is the only chapter where the solutions are very short. Okay, any numerical you catch, the solutions are very short. All the questions are very short solutions. But if we don't remember the formula, how much ever we solve will not be able to solve, will not be able to get the answer. Next question, find x. This is coming 2010. If tan inverse of x plus 2 plus tan inverse of x minus 2 is equals to tan inverse of 8 by 79, where x is greater than 0. And the options are for option B plus 1 by 4, option C plus 4, option D minus 4. Formula tan inverse of x plus tan inverse of y is nothing but tan inverse of x plus y upon 1 minus x into y, x to x minus 2 is equal to here tan inverse of 8 by 79. So now you have tan inverse here also, tan inverse here also. So this tan inverse cancelling here. This 2 is getting cancelled. So here I am getting 2x upon 1 minus 8 plus b minus b, a square minus b square. So that will be x square minus 4 square is equal to here 8 by 79. So here I'll get 2 into 79x is equal to 8 into 1 minus x square minus minus plus plus 16. So I'll get 2 into 79 x is equals to 16 plus 1, that's 17. So minus plus 8 into 70. It's 37. So this I'll bring over here, so I'll get 8x square plus 2 into 17x 8 into 16 equation. Solve this quadratic equation, you will get the answer. So if I'm taking 2 common from everywhere, so I get over here 4 square plus 79x and here 17 into 4 equals to 0. Okay. So now solve this quadratic equation. Solve this quadratic equation, you will get the answer. Chalo. Solve what are the values of x? Solve this quadratic equation. You will get two values of x. Let me know what are the values of x. But you are getting so here it will be x square minus 2 square, so that is x square plus 4. So this will become 5. So this will be, sorry, 4 plus 1, 5. So yes, it will be 8 into 5. This is right over here. Now this is 5 over here. And this become 4. So now your quadratic equation is 4x square to 79x minus 20. Solve. I did mistake over here minus square. Solve this, tell me how much you are getting. How much you are getting? How much? How much you are getting when you are solving 4x plus 7x? So your constant in 4, that is 80. 81 plus 80x minus x minus 20 equals to 0. Here I can take 4x common. Here I'll get x plus 20, and here is it minus 1 is common, so x3 equals to 0. You get 4x minus 1 equals to 0, or x plus 20 equals to 0. So here you will get x is equals to 1 by 4, or you get x is equals to minus 20. But in the question is saying that my value of x should be greater than 0, so my answer should be 1 by 4. So my answer is option number B, that is 1 by 4. Is it clear? Let's do next. Okay, next numerical. This is simple. Sine inverse 3 by 5 plus sine inverse of 8 by 17. Yes. This has come in the year 2010. The option A is cos inverse of 36 by 85. Option B is cos inverse of 85 by 36. Option C is cos inverse of 162 by 85. And option D is sine inverse of 85 by 77. Solve it and tell me. This is very simple. You directly have to apply the formula for sine inverse of x plus sine inverse of y. The formula for sine inverse of x plus sine inverse of y, you will get the answer. You will have to by heart the formulas. So what is sine inverse of x plus sine inverse of y? What is the formula for sine inverse of x plus sine inverse of y? Sine inverse of x plus sine inverse of y is sine inverse of x into under root of 1 minus y square plus y into under root of 1 minus x square. So apply this formula, solve it and tell me what is the answer. So this is your x, this is your y. Apply the formula and tell me what is the answer. So you will get sine inverse of x, that is 3 by 5 into under root of 1 minus y square. So y is my 8 square by 17 square plus y, that is 8 by 17 into 1 minus x square. So that will be 9 by 25. So I will get sine inverse of 3 by 5 into under root of 17 square. So 289 minus 64 upon 17 square plus 8 by 10 into 25 minus 9 upon upon this pi square. So 289 minus 264. So that will give me 225. So I'll get sine inverse of 3 by 5 square root of 225 upon this 17 square will be 17 plus 8 by 17. So 25 minus 9 will be 16 square root of 16 by 5. So I'll get sine inverse of 3 by 5 in the square root of 25 will be 15. So 15 by 17 plus 8 by 17 into 4 by 5. So I'll get sine inverse of 15 into 3. So 45 plus 32 upon 17 into 5. So 45 plus 32 will give me 77. 7 into 5 will give me 85. So this will be my sine inverse of 77 by 85. But if we see in the option, we have 85 by 77. So, but obviously this is not the option. Because after solving, we are getting 77 by 85, and here we are having 85 by 77. So, but obviously, this is not the answer, and all of the options are in terms of cost. Converting cost. Converting cost. So, what is the formula? Sin inverse of x can be written as cos inverse of under root of 1 minus x square. Okay, it is similar to trigonometry. From there only we have derived all these things. Cos square theta can be written as 1 minus sin square theta, and therefore I can write over here as 1 minus x square. Okay. So here if I put this, therefore my sine inverse of 77 by 85 inverse of under root of 1 minus 77 square by 85 square. So I'll get cos inverse of root of 85 square minus 77 square upon 85 square, that is going to give me 85. So either it is option A or either it is option C. Solve and tell me which is the option. Because here I have 85. So here and here I have 85. So either my answer is option number A or either my option is option number C. So again you don't have to calculate, you can clearly see one is 85 square, the other is 77 square. So but obviously when you are subtracting, the answer is not going to be such a bit that I am going to get, when I do square root I am going to get 162. It is but obvious. Okay, it is not option number C. Come on. When you do 85 square minus 77 square, you are subtracting it. So when you are going to get the answer, it is but obviously it is going to be smaller than the additions of the squares of 2. So but obviously it cannot be 162. It has to be this only. So the answer is option number A. So you'll get cos inverse of 36 by 85. Your answer is option number A. Okay. So after simplifying, always see what the options are there. Options will always tell you how much simplification you have to do it. So we have seen many numericals today in which our options that have decided, okay, the amount of simplification we have to do. So next question. This is simple. No, I think so. You should be able to solve this. tan inverse of x by 2 plus tan inverse of equal to pi by 4. What will be the value of x? Options are option D is plus 1, and also given in the question is x is greater than 0 and less than root 6. Find it. This is a very simple numerical. Very simple numerical. You just have to apply tan inverse of x plus tan inverse of y. It is tan inverse of x plus y upon 1 minus xy. Just simplify it, you will get the answer. Very simple. This is come in the year 2008. Very simple numerical. So tan inverse of x plus tan inverse of y is tan inverse of x plus y upon 1 minus x into y is equal to pi by 4. So I'll take tan inverse over there, and here when I simplify, so I'll get 3x plus 2x upon 6 the whole upon 6 minus x square upon 6 is equal to tan of 5 5 x, so 5 equals to tan of 5 by 4 is 1. So this goes there. So I'll get 5x is equal to 6 minus. So I take it over here. So I'll get x square plus I get minus 6 is equal to 0. So 6 1 6. So the factors will be x plus 6 into x minus 1 is equal to 0. Therefore, I'll get x plus 6 is equal to 0 or x minus 1 is equal to 0. So I'll get x is equal to 1. So answer is option number D. Sorry, not option A. The answer is option number D. That is x is equal to 1. Okay, it was very simple numerical. Very simple one. Let's see next numerical. You could have got two answers, minus 6 and 1. In the question is saying x is greater than 0, so we have selected x is equal to 1. See next numerical. Tan inverse of x is equal to 0, where x is greater than 0, then the value of x is so option number A is minus 1 by root 3. Option B is plus 1 by root 3. Option C is root 3 and option D is minus root 3. Try to solve this. Think how we can do this. He has given us the value of this equation. Tan inverse of 1 minus x upon 1 plus x minus 1 by 2. Tan inverse of x is 0. Now you directly cannot apply the formula over here. You cannot apply directly formula over here because the formula is for tan inverse of x minus tan inverse of y. And here you have tan inverse of say this is x minus 1 by 2. So you directly cannot apply the formula of tan inverse of x minus tan inverse of y. So what can we do over here? Or is there even a need to apply the formula? If we see, here it is 0. If I take over there, then I'll get over here tan inverse of 1 minus x upon 1 plus x is equal to this term I take over there 1 by 2 tan inverse of x. This 2 I take over here, so I'll get 2 tan inverse of 1 minus x upon 1 plus x is equal to tan inverse of x. Now can I solve it? If I didn't have this over here, if I didn't have 2 over here, then I could have easily cancelled out tan inverse, and I could have solved it and I could have got the answer. But I have here 2 over here, therefore I cannot cancel out tan inverse, which means you have to think just of applying the formula of 2 tan inverse of x. What is the formula of 2 tan inverse of x in terms of tan? It is nothing but tan inverse of 2x upon 1 minus x square. So that is what I am going to do over here. So I am going to apply this formula over here. So tan inverse of 2. Now instead of x, I have this 1 minus x upon 1 plus x upon 1 minus x square. Instead of x, I have this 1 minus x upon 1 plus x the whole square is equals to tan inverse of x. So now my tan inverse will get cancelled. I'll simplify this. So I'll get 2 into 1 minus x upon 1 plus x the whole upon 1 plus x the whole square minus 1 minus x the whole square upon 1 plus x the whole square is equals to here what remains is x. So 1, this will get cancelled and this 1 plus x square will come up. So I'll get 2 into 1 minus x into 1 plus x upon here. I'll expand this. So I'll get 1 plus 2x plus x square. Here 1 minus minus will become 2x minus x square is equal to x. So plus x square minus x square will get cancelled, plus 1 minus 1 will get cancelled, and here a plus b into a minus b is a square minus b square. Here I'll get 2 into 1 square minus x square upon here I'll get 2x plus 2x, that will become 4x is equal to x. This x will go over here, 2 1s are 2 2s are. So I'll get 1 minus x square is equal to here 2x square. If I take this terms over there, so I'll get 3x square minus 1 is equal to 0. So I'll get 3x square is equals to 1. So I'll get x square is equals to 1 by 3. That is x is equals to plus minus 1 by root 3. So answer is 1 by root 3 because there he has given x is greater than 0. So answer is option number B. That is x is equals to 1 by root 3. Is it clear? Hope you have understood the numerical. Let's do next numerical. An important one. This has come in your advanced. Next numerical. This has come in GW Advanced in 2016. Numerical will look simple. Cos inverse of x plus sin inverse of x by 2 is equals to pi by 6. And if x is greater than 0, then x is equals to option number A 1, option number B root 3 by 7, option number C root 7 by 3, and option number D. Now this is coming your JEE Advanced. When I say advanced, so there are multiple options which are correct. The questions in your JEE Advanced will always have multiple options which can be correct. So in the given question, there can be multiple options which can be correct. Okay, so let's solve it. So now we directly don't have formula for cos inverse of x plus sin inverse of y. We have formula for sin inverse of x plus sin inverse of y, sin inverse of x minus sin inverse of y, cos inverse of x plus cos inverse of y, and cos inverse of x minus cos inverse of y. But if you see here, you have a mixed term over here. You are not having a term directly, you have a mixed term. So how should we do this? If we have a mixed term, something like this, if we have mixed term, something like this, better convert everything in terms of sine or convert everything in terms of cos, whichever you want to do. Okay, either convert everything in terms of sine or either convert everything in terms of cos. So we have this formula, if you remember, sine inverse of x plus cos inverse of x is pi by 2. You can have any x over here. You can write 2x, 2x. The same angle should be over here. I should have same angles over here. So from here I can write sine inverse of x is equal to pi by 2 minus cos inverse of x. Okay. So for here, sine x by 2 Okay, I can write sine inverse of x by 2 is equal to pi by 2 minus cos inverse of x by 2. So this is what I'm going to write over here. So I'll get over here cos inverse of x plus, instead of sine inverse of x, I can write this term. I can write pi by 2 minus cos inverse of x by 2 is equal to pi by 2. This pi by 2 will go over there. So here I'll get cos inverse of x minus cos inverse of x by 2 is equal to pi by 6 minus pi by 2. So now apply the formula for cos inverse of x minus cos inverse of y. What is the formula for that? Cos inverse of x minus cos inverse of y. Pi minus 6 pi 4 pi. Yes, what is the formula? Cos inverse of x minus cos inverse of y is cos inverse of xy plus under root of 1 minus x square into under root of 1 minus y square. So here this will become cos inverse of x into x by 2 plus under root of 1 minus x square into under root of 1 minus x square by 4 is equal to 2 pi minus 4 pi, that will be minus 4 pi by 12. So here I get cos inverse of x square by 2 plus under root of 1 minus x square into under root of 4 minus x square by square root of 4, that will become 2 is equal to 4 1 the 4 3 minus pi by 3. This will go over there. Here I'll get x square by 2 plus under root of 1 minus x square into under root of 4 minus x square, the whole upon 2 is equal to cos inverse of minus pi by 3. Sorry, cos inverse is there, so it will go, so it will become cos. So now cos of minus theta is cos theta. Okay, the cos of minus pi by 3 is the cos pi by 3. So cos pi by 3, that is 60. Cos 60, that is how much? 1 by 2. Okay, so from here I can take 2 common and I can cancel out with that 2. So here I'll get x square plus under root of 1 minus x square into under root of 4 minus x square is equal to 1. Let me take this term over there. Therefore here I'll get 1 minus x square into root of 4 minus x square is equal to 1 minus x square. So now I will square on both the sides. So square and square root will get cancelled. Okay, so I'll get over here 1 minus x square into 4 minus x square is equal to 1 minus x square the whole square. Okay, now directly don't cancel out this term. Now you can write over there 1 minus x square and this will get cancelled out. So you will write over there 4 minus x square is equal to 1 minus x square. Don't do that mistake because there may be multiple options, right? And because of cancelling out, we may not be able to reach to the right answer. Okay, so instead bring this term over here. I can write 1 minus x square into 4 minus x square minus 1 minus x square the whole square is equal to 0. So I take 1 minus x square common. So here I get 4 minus x square minus here what will remain is 1 minus x square is equal to 0. Okay, please don't do this mistake of cancelling out, because this is the numerical of the advance, multiple options will be right, and therefore, because of which we will miss out the option which is there over there. So here I can write therefore 1 minus x square is equal to 0, or we will solve this entire thing. 4 minus x square minus 1 minus minus will become hazard and mistake anywhere. Is equal to 0. So here I'll get x square is equal to 1, and here my x square itself is getting cancelled. So here I'm not getting any option, and here I'm getting x square is equal to 1. That is x is equal to plus 1 minus 1. So my x is greater than 0, so I'm going to get this answer. See if you have understood, and if I have not done mistake anywhere. 5 by 3, so it is 60 degrees. Right. So cos 60 is 1 by 2. Right. Have you understood? What would have happened if I would have cancelled out there? Okay, if I would have cancelled out, I would have got 4 minus x square is equal to 1 minus x square, and this x square would have got cancelled out, and I would have got no solution over there. If I would have done the mistake, if I would have done the mistake of cancelling out over here, I would have ended up with the wrong answer. Have you got it? Is it clear? Okay. So some few more numericals we'll do in the next lecture, and we'll start with the next chapter called as matrices and determinants. Okay, this next chapter, matrices and determinants, is very important. Okay, before starting the chapter in the next lecture, I'll just give you an idea about the questions which are asked in your mains and advanced. So which chapters have what kind of weightage, and this is for last 10 years. So you'll get an idea about on which chapter you have to concentrate. So if you concentrate on certain chapters, you'll be able to do your mains also, you'll be able to do your advanced also. So matrices and determinants is one of them. I will give you one idea in the next lecture. In the next lecture, we'll do only few numericals are left. So that few numericals we'll do of this chapter, and then we'll start with the next chapter, that is matrices and determinants. Okay. Hope you have understood whatever we did today. You will get the recorded lecture once I receive it in my inbox. Okay. Have a nice day ahead.
Hello. Hello.
Hello,
Hello.
hello,
Hello.
hello.
எப்பா எனக்கு நடுவில் நானும் தூங்கிட்டேன்டா நடுவில் நான் நான் முதல்ல நோட்ஸ் எடுக்கல, அப்புறம் நீ எடுக்கிறேன், நீ எனக்கு மனசு கேட்காம எடுத்தேன். நான் மேக்ஸிமம் ஆனால் ஸ்க்ரீன்ஷாட் தான் போட்டு வச்சேன். எனக்கு ஸ்க்ரீன்ஷாட்டும் எடுக்கலான்னா பாதி நேரம் ஒழுங்காவே தெரியாது, எனக்கு போர்டே ஒழுங்கா தெரியல.
ஆகாஷ்
ஆகாஷன்
ஹாய்.
ஏதோ ஒரு குத்துமைப்பா போட்டோ எடுத்து வச்சிருக்கேன்.
ஆகாஷ்
இன்னைக்கு ஃபுல்லா ரெஸ்ட் எடுக்க வேண்டியதான். இன்னைக்கு வேற எதுவும் படிக்கிற மூடு இல்ல.
ஓகே, ஐ சே குட் நைட்.
ஆக்சுவலா நான் இன்னைக்கு என்ட்ரன்ஸ், நீ மேக்ஸ் ஏதோ சொன்னியா, நான் ஆக்சுவலா மேக்ஸ் பிடபிள்யூ மட்டும் இன்னைக்கு பண்ணலான் இருந்தேன். அப்புறம் நீ என்ட்ரன்ஸ் பத்தி சொன்னோன்னே சரி என்ட்ரன்ஸ் பிடபிள்யூ பண்ணலாமான்னு யோசிச்சேன். இப்ப எதுக்குமே மூடு இல்ல, படுத்த வேண்டிய.
வெரி குட்.
இதுவும் ரெக்கார்ட் ஆயிட்டு இருக்குமா? இன்னும் ரெக்கார்டிங்னு வருது கிளாஸ்.
பாய்.